Welcome to Learning Redis, Section 8, Winners and Losers. So having now set up our implementation using Redis lists to track the players' trades and turns, we're getting very close to finishing our game. We just have a few more elements to take care of. In this section, we'll learn about the sorted set. We'll figure out how we can determine if a game has ended and who won, and we'll implement a game leaderboard that can display our top 10 players. But to have a social game, we're going to need a leaderboard that tracks those high scores. So let's look into how a sorted set in Redis works and figure out how we can use that structure to our advantage here. Video 8.1, how does a sorted set work? In this video, we'll look at the Redis sorted set structure. I'll introduce the structure, we'll talk about how it's used, and then we'll see how it could be applied to a game leaderboard. Now, you've already been introduced to a Redis set. As we learned, a set has a few basic constraints. Its elements are strings, which are unique throughout the set, and the elements are unordered. We use this property of set to provide a randomized bag of tiles to draw from. But now we're going to look at the Redis sorted set. It retains most of the properties of a set, but adds a twist. Unlike a sorted set is ordered by a floating point score value that you associate with the element when it's inserted. And unlike a Redis list, which merely maintains the order of item insertion, forcing us to determine the order, the sorted set will always maintain the elements in ascending order based on the scores that we associate with them. So let's look at the basic commands you have available on a sorted set. Some of them, like zadd, zrem for remove, and zcard for cardinality, those will look familiar from using the set before. The only real difference is, with zadd, you now need to specify a score. Similarly, there is a z-score that retrieves the score associated with that member. There are a couple new tricks here, though, dealing with rank and count. Now, rank is the position of an element in the sorted list. If the element is at the front of the list, in other words, has the lowest score, it will have a rank of 0. If it's at the end, it will be equal to the number of cardinality of the list minus 1. Conversely, using zrev rank, we'll reverse the rankings and assign rank 0 to the highest score. Finally, zcount will retrieve the number of elements that exist between the min and max scores specified. So let's look quickly at a couple of those commands in context in the Redis CLI. I'll create a sorted list that has the names and numbers 1 through 5 and assigns each one a score equal to the numeric value of that number. Okay, we'll assign 1, 1, 2, 2, 3, 3, 4, 4 to 5. Okay, now let's look at zcard of the numbers, and as expected, we have 5 elements. Also, if we z-score the element called 4, Redis returns our score 4. But now if we z-rank that same element, we see that we have a 3. Can you care to guess what the z reverse rank of element 4 is? Z rev rank. Well, if you guessed 1, you were correct. It is the second element after 5 in the reverse ranked order, so the rank is actually 1. Now, one more thing. What will we get if we get the z count with a minimum of 2 and a maximum of 3? Aha, it's inclusive by default, so we get 2. If you want exclusive, you just need to add an open parenthesis to the min or max to exclude. So let's actually add it to our max, the element 3, and Redis will now tell us that we have just one element greater than or equal to 2, but less than 3. So that's pretty cool, right? But there's some even more valuable stuff you can do with sorted sets. You can work with ranges. Now, Redis gives you the ability to query and manipulate ranges using scores and rank, and in some cases, lexical information. But we're not going to cover these cases here. zRange and zRevRange allow you to query your set by rank position and optionally include the scores of the elements returned. Now, likewise, zRange by score and zRange by rev score allow you to do range queries by score. And zRem range by rank and zRem range by score enable you to remove a range of elements in a similar manner by rank or score. So let's drop back into the Redis CLI and take a quick look at some of those commands. Now let's say we need to get the top 3 highest numbers in our set. So we can call zRevRange numbers 0 to 2 with scores. And you can see that that will give us the highest ranked number to the 3rd highest ranked number and include each element's score. So the elements and scores are 5, 4, and 3. So we have a high score list. Now that really does seem useful in the context of a game, doesn't it? But now let's say that we don't care about any scores below 3. Now we can throw them all away with the zRem range by score command, right? But first, let's check it out. Let's issue the command zRange by score, numbers 0 and less than 3. Yes, indeed, that selects scores 1 and 2, which, we don't care about at all. So let's issue the real command, zRem range by score numbers 0 less than 3. It returns 2, which means it deleted 2 records as expected. So now let's look at everything left in our set by using zRange by score numbers -infinity to +infinity. That will give us everything, and indeed 3, 4, and 5 are left. Perfect. Okay, now that we've covered the basics of sorted sets and how they differ from a standard Redis set, let's get back to the game and get it finished and scored. So next up, finishing the game.